Hey guys, so today we're going to do a video about the rational roots theorem, and it's also called the rational roots test, and we'll just go through what it's used for and really what it can do. So what we have here is we have a really confusing looking definition. We have f of x equals p times x to the n plus q times x to the n minus 1 plus r x to the n minus 2, blah blah blah, all the way until we get to this constant c. But what I want you to notice, let me get a different color out, is that the only thing that we need to worry about is c and p. And just know that p is the leading coefficient, so that's the coefficient in front of the highest degree, whatever the highest degree is, and c is the constant. And then what the rational root theorem says is that if the function has rational roots, they will be plus and minus factors of c divided by factors of p. So let's just look at that in an example. We've got the function 2x cubed plus 3x minus 5. So now we can say, well, first thing I want to do is I want to figure out my p and c. My p is going to be the coefficient in front of the highest x term, the highest x degree, and the highest x degree is 3, and the coefficient is 2. So p is 2. Then my c is just my constant value, and in that case that is negative 5. Then now I know back at the formula it's going to be plus and minus all my factors of c, which is going to be factors of negative 5, divided by all my factors of p, which is factors of 2. And now let's think, I'm just going to draw my big bar line, fraction line I guess I should call it, and just write down all the factors of 5 and all the factors of, negative 5 actually, and then all the factors of p. So I've got plus and minus 5 and 1, those are the only numbers that go into 5. I can make this a little smaller, I don't have really big numbers. Then we've got plus and minus 1 and 2 for 5. For 2, I mean. So what this means is that all the rational roots that could be are listed right here, and if we wanted to write that out in like a full list, we could say, well, we could start with plus 5 and divide by 1, starting positive on both top and bottom. Then now what if we made it negative 5 and used positive on the bottom? Then we'd have negative 5 over 1 and negative 5 over 2. And then also we would now we can move over to the 1. We can say 1 over 1, both being positive. Then we can say 1/2. Then now we can make them negative. We can say negative 1 over 1 and negative 1/2. So now let's simplify a bit, clean up. We've got 5 over 1 is 5. Then we've got 5/2. We've got negative 5. We've got negative 5/2. We've got positive 1. We've got positive 1/2. We've got negative 1, and we've got negative 1/2 finally. So these right here, these are the 8 possible rational roots, and if you wanted to, you could even simplify. This is what I like to do. I would just write plus and minus outside, then say 5 over 2, 1, and 1/2. And that would be the same as writing all 8 of them out like that. And now what this means is these are possible rational roots. So then what we would do with this is we would start dividing synthetically, and this would help us, and if the remainder is 0, that would mean that it is a factor. And also a quick way to do it is you could plug stuff in to the original function. So we could plug in this factor if we wanted to test like 1 or negative 1 in for x, and if the function gives us 0, it is a factor. So let me do a quick example of that. So is we'll start with negative 1 a factor. And what we're looking for is if f of x is 0 when we use negative 1 as x, then it is a factor. So let's say we've got f of negative 1 equals 2 times negative 1 cubed plus, I think it's 3 times negative 1 minus 5. So 3 times negative 1 minus 5. So that's going to be negative 1 cubed is negative 1, so we got negative 2 minus 3 minus 5. That equals negative 10. So f of negative 1 is negative 10, which does not equal 0, so no. F of negative 1 is not a factor. Let's try is 1 a factor. Remember that we are looking for when it equals 0. If it equals 0, it's a factor. This is just a quick way to test without doing synthetic division. So now we can say 2x cubed plus 3x minus 5, f of 1 equals 2 times 1 cubed plus 3 times 1 minus 5. So that equals 2 times 1 cubed is just 2, plus 3 times 1 is just 3, minus 5. Well, that's going to be 5 minus 5 is 0. So f of 1 equals 0. So is 1 a factor? Yes. That is a rational factor of this function. So that means it's a 0. That's why we can plug it in, because roots are the same as zeros. They mean the same thing. So what the rational root theorem helped us do is it helped us figure out our possible rational roots, and that makes it a lot easier to figure out the actual roots because we can check them. Be careful though, because just because they are possible rational roots, most of them will not actually be factors. Just like this -1, it wasn't our possible rational roots, but it was not actually a factor. So really this theorem, what it does is it gives us some values to check. It does not necessarily provide answers. Hope this was able to help. Thanks for watching, guys.